Hello, in this video we will see some basic continuous time signals which are the unit step signal, unit impulse signal, unit ramp signal and exponential signal and a sinusoidal signal. Okay, so let us start with the first signal, unit step signal. So the first one, unit step signal, it is represented by u of t and it is defined as u of t equal to 1 for t greater than equal to 0 and 0 for t less than 0. Okay, and now if you plot this signal, you will get this is t axis and it is 0 before t equal to 0. So this is t equal to 0 and we are plotting u of t. So this signal is 0 before t equal to 0 and it is 1 after t equal to 0. Okay, and so on. So this is the unit step signal. Now the unit step signal is useful for the convenient representation of various signals. Okay, so this unit step signal can be used to conveniently represent the signals. Okay, for example, the causal signals are one which are 0 for t less than 0. So causal signals are 0 for t less than 0. Okay, so a causal signal is one which is 0 for t less than 0 and it starts from t equal to 0. So for example, an exponential signal e to the power minus at is an everlasting signal. So this is e to the power minus at. Okay, and this is an everlasting exponential. It starts from t equal to minus infinity and continues up to t equal to plus infinity. So if we want to retain only its causal part, means only after t equal to 0, so what we need to do, we can just multiply this signal by a unit step signal. So this is t, so this is u of t which is 1 for t greater than 0 and 0 before t equal to 0. So if we multiply this two signal xt into u of t, what we'll get is that this part of this signal will multiply with this 0 and it will be 0, and this part will be multiplied with this part of the unit step and we will get only this signal. So this signal is x of t into u of t, which is e to the power minus at into ut. Okay, so this is the causal part of this signal. Okay, now we can see a few more examples. For example, we want to represent this pulse. So this is a pulse. A pulse is a signal which is non-zero for a finite duration of time and it is 0 otherwise, and this amplitude is say 1. So this is some signal x of t, and to give its mathematical description we have to define this as a, we have to define the signal in this way. So this is 0 for t between 2 to 4, and it is again 0 for t greater than equal to 4. Okay, this is the piecewise equation. Okay, so this is one way to represent this pulse by this piecewise equation. Now another way we can represent this signal in terms of unit step signal. For example, what we can do, we can have a unit step signal which is shifted by 2. So this signal is u of t minus 2. Okay, its amplitude is 1. We can have another signal u of t minus 4 and with negative sign. Okay, so this signal will be like this. Okay, so this is minus u of t minus 4. Now if I add these two signals, if I add this signal and this signal, what I will get? So we will have, so from 0 to 2 it is 0, and then after 2 we will have 1, and as we reach at the 2, this signal will be subtracted from the above signal, from this signal, and so after 4 this signal will become 0. Okay, so this is the resultant signal x of t equal to u of t minus 2 minus u of t minus 4. Okay, so we have represented that pulse x of t in terms of the unit step signals. Okay, so we'll stop here and continue with the remaining signals in the next lecture. Thank you.